Hello, this is Mr. McMurray, and we are trying some new technology for recording and also for lighting. So we'll see if that improves things or not. Feel free to make comments and send them to me if it's better, worse, whatever. All right, but with new technology comes opportunity for new ways to mess things up. So we'll see how it goes. Anyhow, so we're talking about for unit, I believe, number 6, the harmonic motion of a pendulum. Okay. Um, and basically, we're talking about two kinds of energy here, potential and kinetic energy. Kinetic energy being moving, and to be particular, gravitational potential energy, which has to do with the position, because the higher up something is, the better the chance that it has has the potential to gain kinetic energy when it falls. All right, gravity being always around and so forth, so that's always there. All right. Anyhow, some terminology also. We have a pendulum. Okay, a pendulum is attached up here, and then it has swinging, usually a ball shape, but it could be whatever. And if we expand this so we can see what we're doing here. All right. If we hit play, all right, they're going to let go of, I guess, a little magnet switch here. And once they let go, then it lets go of the ball and it will begin to swing. Now, the time that it takes to swing over here and come back is a period, okay? A period is just anything that repeats. The periodic table is a certain pattern of elements that repeats every so often as they go across the rows, okay, which if you're in the next semester, we will go over. In this case, it is where it starts here, swings all the way out, and comes all the way back would be one period. And the length of time would be the time it takes for it to do that, okay? Tools, real quick, that you'll be using for this one, stopwatch. Okay, so for example, if we went back to this before it was released, let me move that out in the middle of the picture there so we can see what's happening here. Okay, if we go back to right where they released their finger off, okay. All right, so right there and right about there is their letting go. Okay, so it's going to let go. Now, once again, if you want to time how long the period takes for it to come back, you're going to have to hit the little reset button here to set it back to 0 seconds. Okay, and then you can play it forward. Or if you get tired, you can always just play with it this way. Scroll it across, it goes up, it comes back. And we'll use a little fast forward button. All right, and so we're about there. So that would be my time right there. Now, obviously, there's a little bit of wiggle room here, exactly where does it hit and whatever, but trying to get as close as we can. Okay, so that would be the time it took for one period. Okay, now one of the other characteristics we're going to measure at times may be the length of the string. See how changing the length of the string might affect that. So I would measure it from the bottom of that little screw there. As long as you're consistent wherever you measure it from. I'm going to measure it from where the string comes down there. All right. And then do you measure at the top of the ball, the middle of the ball, or the bottom of the ball? That's up to you, but just be consistent, whichever you do. If you measure at the bottom of the ball, then measure at the bottom of the ball all the time. But basically, we're really just wanting to know how long the string is. And so this would probably be best to do it when it is hanging straight down, okay? And that will give you the most accurate. So I would call that 38. If you were doing the middle, you could call it 40. If you were doing it at the bottom, you could call it 41.5, whatever. That's up to you, okay? But wherever you do it, measure from the same place on each one. Because if you measure one ball at the top and one at the bottom, that's going to mess up your answers a little bit there, okay? Now, another thing that's going to change is how far do we bring the ball up or down, okay? And so, actually, this one would probably be better just to start off at the beginning because that's as far as it's going to go, okay? And you would click on the protractor here, all right? And the protractor has a little crossbars right here, right there. Those crossbars you need to line up right with the line where it started out right there. Once again, it might be good just to measure when it's straight down. Okay, should be at 0, so that's pretty accurate, looks like. Okay. Like I said, you'll have to kind of go with that and get it lined up. You want the string, it comes straight down the middle, to be at a right angle to this horizontal line, and just like so. Okay, now when it's back here, then you would measure how many degrees. Okay, and so in this case, you've got 15 here, so then you get two bigger marks in between, so it'd be 5, 10, and 15. So it looks like about 5 to 6, 5.5 or 6 there. So I'd say it's at 6 point, excuse me, 5 point, or just 6 degrees, okay, off. Now, just for the record, when it comes to the other side, it should also be about 6 degrees off. But we'll do it from the starting, the release angle. How high did we lift the ball, and is that going to affect how long it takes for it to make a period or not? Okay. Now the last variable is mass, and mass you will have to do over here. Okay. It also gives you different release angles and different lengths. Okay. So as you, for each experiment, to find out how it's going to affect it, you're going to have to try different lengths. When you want to know the release angle, how that affects it, you have to change the release angle, and you're going to have to change the mass. Okay, but when you're studying, say, the mass, you don't want to change the release angle and the length and the mass, because then you don't know which one caused your results. Going back to our first chapter, you've got to have a control group, or not control group, but you need to have experimental. You only need to change one thing in the experimental. In other words, just the mass. Okay, and then you can say, oh well, by changing the mass, this is what it did to the length of the period, if anything. Okay, when you're changing the release angle, you don't want to change the mass and whatever. Also, because then you don't know which one caused it, so you want to just change the release angle, keep the same length of string, keep the same mass. Okay, you may want to experiment with them just to see, because, for example, at this particular length, there are only two masses to choose from. Okay, notice the other ones are grayed out and will not let you use them. So you might want to pick a different release angle that will give you, I'll give you one too. So see if you can find one that gives you more choices. There we go. Now we got lots of choices, okay? And so you may just have to fiddle around to see which one gives you the most choices. All right. And so on. All right. So basically, you're going to do an experiment to test these different things. Then you're going to make graphs. All right. Let me get out of this video, or lower where we can see the rest of the stuff. Okay. Like I said, you can change the different things. For the first one, I put mass. So you're going to change the different masses, try different masses. Notice when it says length, it's talking about length of the period, which how long it takes to go to one side, back to the other side. So we're talking time here. Okay, it doesn't have anything to do with the length of the string. Okay, that's different. All right, so you're going to do that for different masses, see how long it takes, and then graph that on this title, deciding which one is your independent variable, the one that's going to be happening no matter what. Okay, and which one are you changing, or you're doing your messing with? That goes over here on the left. Okay, and then once you get your graph, you're going to tell me basically how did that affect it. Did it make it faster, slower, or what, and how did that affect? Okay, and also, like for example, mass, did increasing the mass make it go faster, or did decreasing the mass make it go slower? Don't just say, oh, it made it go faster. Well, what made it go faster? More mass, less mass? Okay, don't forget that. Okay, then the next one, length. This time we are talking about the length of the string, and we're seeing how it will affect the length of the period. So you're going to change the length of string, string, and let me email. I don't know if y'all can see those or not, but anyhow, hopefully you can. Anyhow, length of the string, and how many does that affect the length of time that the period takes to go all the way over and come all the way back. All right, and then once again you'll graph it, and then you will describe the relationship for me here under the next one. Then the last one, this time you're going to change the release angle, so it's going to be pulling it farther back and seeing if that affects the time it takes for the period to go. Once again, you're going to graph that, and in a word, you're going to tell me whether it did or not. All right. So basically not too hard. It got a few little wrinkles, but basically a pretty straightforward lab. Hope you enjoy it, and we will see you at the next lab. Thank you. Enjoy.